Good morning, good afternoon, or good evening, my friends, whenever you are watching this video. Welcome back to another math time with me, Miss X. I am super excited to have you all here again. Let's begin by looking at our objectives. Remember, our objectives are always broken up into 3 separate parts so we know exactly how we're going to do something, what it is that we need to understand, and lastly, why we're doing it or why it's important. So you may read with me or in your head as I read out loud to you. I can use the make 10 ones or make 10 tens strategy to solve addition problems that have up to 4 addends in order to prepare myself for solving math in my head. And that's what we call mental math, my friends, when we are able to solve math in our head very quickly and without paper and pencil. Let's jump straight into our teacher model. All right, friends and families, welcome to the teacher model. Go ahead and take a look at our example for today, or our first part. You'll notice that we have 3 addends rather than our normal 2 addends. And remember, addends just means part. So instead of 2 parts, we have 3 parts today. And this is really important because our objective is telling us that we're going to be working with up to 4 addends or more than 2 addends in order to practice the make 10 strategy. We've been able to make 10 in the past, and we also learned how to make 10 in the past, but now it's really important for us to see it when we do work with double digit numbers and single digit numbers as well. Without counting one by one and without drawing pictures or anything like that, I want you to go ahead and think to yourself, what is the answer? Go ahead and take a few minutes to think about it, and then we'll come back as a team and talk together. If you were thinking 16, you're correct. Well, what helped you solve so quickly? Well, 3 plus 7 I know equals 10. And then 10 plus 6 is 16. So that means 3 plus 7 plus 6 must equal 16. Moving on, we have another problem, or another number sentence. 23 plus 27 plus 16 equals. Now, don't use vertical addition to solve. I want you to use mental math. Pause the video here and talk to a friend or a family member using place value language how you could solve this problem mentally. Then we will come together and show our work. I'm going to go ahead and use place values to support me in my mental math today. I'm going to break up 23 into 20 and 3. I'm going to break up 27 into 7 and 20. I move the 7 over here, and you'll see very shortly why. And then 16 into 10 and 6. 7 and 3 make 10. Now, I can go ahead and just add 20 plus 10 plus 20 plus 10 plus 6. I know that 20 plus 10 is 30, 30 plus 20 is 50, 50 plus 10 is 60, 60 plus 6 is 66. Therefore, 23 plus 27 plus 16 is equal to 66. Remember, my friends, when we add, you can arrange or rearrange the addends however is best for you to see. For example, I didn't have to write 20 plus 10 plus 20 plus 10. If it's easier, I can do 20 plus 20 plus 10 plus 10 plus 6, because 20 plus 20 is 40, plus another 10 is 50, plus another 10 is 60, plus 6 is 66. When we add, it does not matter how you add in terms of which ones you add first. Remember that in addition, we have what we call commutative property. Remember, in commutative property, it only applies to addition. When you're adding, it doesn't matter the order in which you add. You will still get the same solution or whole. All right, my friends, I've added a new number sentence. Now, pause the video here and think to yourself, how is this problem the same as and different from the first two? So, how is this problem the same and different from the first two? We will come back and talk together about it as a team. So pause the video here and then think about it, and we will talk about it together. Welcome back, my friends. So, if you take a look, you'll notice that the ones are the same in all the problems. The ones are the same in all the problems. And I'm going to underline it in red so that you can see it clearly. Now, you'll also notice that in the second and third problems, the tens and the ones, so the tens and the ones are the same in the second and third problems. But now, in the third problem, there's 100. In the first problem, all the numbers have only one digit. They're only one digit, meaning they only have one number. Whereas the second, they have two digits. In the second set, they have two digits, which is 2 and 3, 2 and 7, 1 and 6. So each number has two digits. And then in the last problem, one number has three digits. If you break up 123 into 123, it's the same. It's pretty much the same as the second problem, because 23 plus 27 plus 16. It's pretty much the same as the second problem, except it has an extra addend of 100. So therefore, if we know that 23 plus 27 plus 16 makes 66 based on the second problem, if we add a 100 to the 66, our solution would be, if we add a 100, our solution would be 166. Okay, my friends, moving on to the next part of our teacher model, we have 4 addends now instead of 3. Pause the video here and talk with your friend or a family member about how we can easily solve this. I'll give you a hint. We can use the make 10 strategy that I have been reiterating since from the start when we've seen our objective. All right, my friends, welcome back. So, we know that 1 and 9 make 10, and then 3 and 7 make 10. So, this whole, or the solution, would be 20. This means that we can add numbers in any order. In fact, I'm going to rewrite it so it's super easy for us to see. I'm going to rewrite it as 1 plus 9, and then plus 3 plus 7, just so that it's easier for me to see it. Again, when we add, we have commutative property, meaning it doesn't matter which order we add in, it will always give us the same solution or the same whole. I can now more easily see that 1 plus 9 is 10, and that 3 plus 7 is 10. Therefore, my whole is 20 in all of them. All right, my friends, I've added another number sentence to our problem here. I want you to think to yourself, how is this problem the same as the first problem? Look carefully. Great, the ones are the same. Now think to yourself, how is it different? How is the second number sentence different from the first? Yep, now there are tens. Great job. Okay, my friends, so I don't really like how this is arranged currently because it's very difficult and it looks super overwhelming for me. So I'm going to rearrange it so that I can see tens more easily and I can make tens more easily. So watch as I rearrange it, and I'm going to rearrange it in blue so I don't get confused. I'm going to keep 31 here, but I'm going to move the 19 here. Then I'm going to add 23, and then I'm going to add 47. So I just rearranged it because we learned recently that we can rearrange and add in any order due to the commutative property that we learned about in first grade. Alrighty, I'm going to break up 31 into 30 and 1. Whoops, let's fix that. I'm going to break 31 up into 30 and 1. I'm going to break up 19 into 9 and 10. I'm going to break up 23 into 20 and 3, and then I'm going to break up 47 into 7 and 40. You'll notice that the way that I chose to break it up, I made it so that it's super easy for me to see the make 10. 1 and 9 make 10. 3 and 7 make 10. Now I'm going to go ahead and solve it. Again, my friends, when we add, it doesn't really matter what order you add it in because you will always get the same solution. So I'm going to add 30 first, and then I'm actually going to add the 20 next because I know that that makes 50. Then I'm going to go back and add that 10. I'm going to add that 10, and I'll check it off too so I don't get confused. And then I'm going to add that 10. Then I'm going to add that 10. And then I'm going to add 40. Alrighty, my friends, let's go ahead and take a look at our work. I see 30 and 20 make 50. And then I see that 40 and 10 here make 50. That means that I can rewrite it as 50 plus 50 plus 10 plus 10. I know that 50 and 50 gives me 100. Oops, I'm going to go ahead and circle that in black so I don't get confused. Gives me 100, so 100 plus 10 gives me 120. Therefore, 31 plus 23 plus 19 plus 47 is equal to 120. Even though I rearranged it and regrouped it into tens several times, I still got the same answer. And remember, my friends, I also used check marks to help me keep track of the numbers that I have already worked with. This way, I don't get lost, I don't get confused, and I don't forget any important numbers. You may also practice those same strategies in order to help you stay on top as a mathematician. Alright, my friends, welcome to the last part of the teacher model. I have 61 plus 53 plus 19 plus 27. Now you'll notice again, we have the same ones for each of the problem sets. Now you'll notice also that for the last set, that third set, the tens are different from the second set. So even though the tens are different, they both have double digits. Whereas the first set still only has one digit. Let's go ahead and rearrange our number sentence in order to help us see tens a lot easier. Let's go ahead and do that. So 61 and 19, and then 53 and 27. That looks so much better to work with. Alrighty, let's break up 61 into 60 and 1, 19 into 9 and 10, 53 into 50 and 3, and then 27 into 7 and 20. Let's go ahead and see if we can see any make tens. I see a 10 there. I see another 10 here. Great. And again, in math, not in math, in addition, we can do and use commutative property, meaning we can arrange them in any order and add them in any order without changing the solution or the whole. So let's go ahead and do that. So I have 60, and again, you can go ahead and use check marks to help you keep track of the work that the numbers that you've already worked with. 60 plus let's go with 10. Uh-oh. Sorry about that. Plus 10. I just used that 10. Plus 10. Great. Plus 20. I'm going to check mark this off. Okay. Plus, oh, I still have that 50 there. I'm going to check mark that 50 as well. And then I have my last 10 there. Plus 10. Great. Whoa, this feels very overwhelming, so I'm going to go ahead and step back and see if there are any easy number pairings for me to work with. I see that 50 and 10 make 60. That looks a lot easier for me to deal with. Okay, and then I notice that, oh, 20 is here, 30 and 40. So 20 and then 2 10s would give me 40. So 20, 30, 40. Oh, and then 40 plus 60 would make, oh, this would make 40. And then that's still 60. So 60 and 40 would give me, oh, we still have that 60 right there too. And I'm going to check mark these friends off because I used them. Well, I noticed that 60 and 40 make 100. So then 100 plus 60 would equal 160. Oh, that was so much easier to work with, my friends. It's really important that we see make 10 for both our 1s and our 10s. Down here in this problem, it was very difficult, and we used the make 10 10s in order to get a 100, in which we added 60 more to give us 160. Therefore, our solution is 160. 61 plus 53 plus 19 plus 27 equals 160. Okay, my friends, as you get ready to move into independent practice and your exit ticket, please keep these 5 things in mind. Number 1, rearrange the different addends if you see partners of 10. Number 2, when you are done rearranging, break each addend up using mini number bonds like I did. Number 3, look to make 10 1s or 10 10s and then circle them together. Number 4, keep track of your numbers with check marks so you are adding correctly, kind of like I did in the teacher model. And then lastly, try not to use drawings like the place value disc, chip model, or stick sketches. This is very important because we are trying to build our ability to solve math problems in our head. And lastly, don't forget to click the link in the description box below. It will take you to the worksheet. Don't worry about printing it if you don't have access to a printer. Just write down the problems on a separate piece of paper and solve it on your own the best that you can. Good luck, my friends. I'm looking forward to seeing you all in the next math lesson.